Here we have a problem that reads, if molecules diffuse distance 6d in 2 seconds, how far will they diffuse in 8 seconds? So this is a random walk problem, and more specifically, it's a one-dimensional random walk problem. And so our equation for random walk in one dimension is x RMS, which is our distance, our root mean square distance, equals square root of 2dt, and this is where d equals our diffusion coefficient, and t equals time. And so, what is our diffusion coefficient? Well, our diffusion coefficient equals d equals 1/2. We can either say v d, or it equals 1/2 d squared over change in time. And of course, I think it's pretty obvious to see that here v equals d over change in time, which is exactly what velocity equals, right? And so, obviously we have 2 times here, so it's like, okay, which time do we plug into each one? Well, one of these times is giving us is part of calculating a velocity, right? So, if we look at it, this molecule is traveling 6d in 2 seconds. So with that being said, okay, we know the distance traveled in 2 seconds is our velocity. And then we are going to use this velocity, write this into our diffusion coefficient. That will give us later on our x RMS. But we need to find what our velocity is for this problem initially, right? So the first thing we're going to do is just say that d equals 1/2 6d squared over 2 seconds, which equals what? 1/2 36d squared over 2, which equals 1/2 18d squared. I'm going to leave this 1/2 out in front because you'll see whenever we plug it into x RMS that our 2 and our 1/2 will cancel out. So now from here we have what our diffusion coefficient is. We're going to plug that into our x RMS, and we'll get that x RMS equals the square root of 2 1/2 18d squared times 8. So you can see our 1/2 and our 2 cancel out, and then we get that square root of 18 d squared 8, which is the square root of 144 d squared. Everyone knows the square root of 144 is 12, and then the square root of d squared is d, so we can say that our x RMS equals 12d, and that if molecules diffuse distance 6d in 2 seconds, or if they have a velocity of 3d per second, then they will diffuse a distance of 12d in 8 seconds. And so here we have another problem where it says, if molecules diffuse distance d in 1 second, how far will they diffuse in 4 seconds? Well, same process. I would say pause the video, do this one on your own. And we will start off by saying the same thing, that x RMS for one-dimensional diffusion is 2dt. And so for our diffusion coefficient this time, we'll use 1/2 vd, which is obviously going to give us the same answer. But it's just kind of another way to see how to solve this. We can say, depending on what information the problem gives you for next time, but we'll say that v equals d over 1, and we'll plug all this into our diffusion coefficient. And we'll say that d equals 1/2 d over 1, and realize that I'm plugging in a d for d. It just so happens that the distance we're traveling is d here, even though that's what we're substituting in. But go back to the other problem, make sure that, you know, on the last problem, this was 60. So make sure if whatever D is, that's what you're plugging in for your D. So if this was 60, then we put 60. Obviously it's not, it's just D in this problem. So we're going to say D, and we're going to say our diffusion coefficient equals 1/2 D squared. We're going to plug this into our XRMS and get XRMS equals square root 2 1/2 D squared times 4. Our 1/2 and our 2 cancel out, and we get that our XRMS for a molecule with a velocity of d units per second, we're going to say is 2 d after 4 seconds.